Okay, so link validation and commissioning. Link commissioning. Validate the link settings. So what we do here is verify traffic, verify stability, fine-tune parameters if required, record the state of the link after verification, sends documentation for troubleshooting down the line, provides proof of the job was performed correctly, acts as a gate for release of the link to the end customer in live traffic. We provide a sheet on the back of the Giga Plus. This is also on the website. This is suggested by Triangle. However, you can do your own sheet, whatever you want to use, your own parameters, or what's important to you when you actually release the link to your customer. First of all, we're going to verify the RF signal quality. How do we do that? We're going to do a link test. Okay, all must be ones. All the links should be ones. Dmca must be a acceptable threshold. Again, remember the table we showed you with the ACM? We want a 1024 QAM link. In this case, we're going to have at least an MAC of negative 35.20. That is a threshold. Anything from 35.10 and below is going to jump to 512. So you want to have the best MAC possible. Now that threshold is going to tell you how strong is your link. The more our MAC value threshold above that, if it fluctuates down, you're going to still get a 1024 QAM. RSSI must match the expected target RSSI. As we said before, within 3 dB, so the expected target RSSI, it's, well, you can actually live with that link. That is a good link, 3 plus or minus. Link test command will show you the quality of the signal, bit error rate, RSSI, and modulation level. Test can be run over a period of 99 iterations. So at the bottom we have a link test. So we have the locus 1, RSSI negative 46, our MAC, BERs. I'm going to touch base on BERs, bit error rates. Now BERs are only errors over the air. When you have BERs, typically it's going to be a transient problem, RF related. BERs are not going to be like the IF cable installation. BER are mostly related to RF problems only. So when you have BER, you gotta start looking at what? First you look at ACM. Did it went up and down? If there's a constant shifting up and down the radio, if it's too constant too frequently, that will actually create BERs. Okay? So it's hitless, but it's designed to act ACM on the actual weather going bad, fog, thermal invasion. If it's just going up and down because of power reasons, that will create a problem. So when you have BERs, it's not that it could be an equipment problem. It may be interference as well. Somebody transmitting really close to you. That's also a possibility. Site validation. So the form we have here is an example. We have site information. Who's the customer, the site name, site address, the coordinates, the radio model, radio serial, site access nodes. So in this business, when you have a tower site, and it's an American tower site, you're gonna have your own path log, you're gonna have dedicated access, the works. But when you're renting space from a private or infrastructure on a building, things like that, sometimes you gotta jump through hoops to get to the site, right? You gotta go through properties, you gotta open gates, you gotta climb up, mountains. Make sure all that is documented somewhere, because if you send a field guy out there, yeah, well, remember to get the key from the office and then run to the storage and get, the generator and then get the tools, and the little process, small as it may be, is worth documented, because we don't want somebody to go out there and, for example, for us, on one Woodson, there's 2 keys. There's one for the gate to open out the actual access to the trail, and then when you get to the tower side, the shelter has 2 special keys. So imagine me going up there and then forgot the actual key to the shelter. That would be a waste to drive 40 minutes. So site access nodes, document as much as possible, get every little detail down. Antenna installation, antenna model. Is it a T2 antenna? Is it a 4-footer, 6-footer, whatever it is? Antenna height, make sure it actually matches. Fresnel zone, is it impacted or not? Antenna mount, is it secure? Antenna, is the antenna properly grounded? The ODU is grounded. Was the O-ring installed correctly? Now, speaking about O-rings and antennas,
does a combiner have 3 O-rings?
It has one on each side, and the front.
Yeah,
Depends, because the OMC, you have to take off the actual path in front and then just slice directly to the antenna mount. Because the waveguide is different. You gotta take off the waveguide on the antenna, and then there's another adapter that goes there.
Yeah. Great. So basically, each hole needs an O-ring.
Yeah. Now, inside of here, when you get your radio, you're gonna have a little packet with dielectric grease and a street name we know, finger condom. Okay? This is because you're going to put the grease in the actual ODU before you stick it on the back of the antenna of the combiner. This is for waterproofing as well, the connection. Indoor unit is properly mounted on the rack. As we said before, the grounding lug on top, it's not to pinch your finger, it's for actually grounding the actual IDU. Is there sufficient space between the rack and the proper ventilation? Now remember, the IDUs are designed like a switch, network switch. So the vents are facing sideways. Cables are properly labeled. Oh, good point. We have to label the cables, right? Because what happens is, and it happens to me once in a while, I won't say every time. So the IF cable, when it goes up the tower, it's going to go next to this bunch of cables going out on the same railway. Okay? So just to pick your own cable is going to be real difficult. So typically what installers do is they color code, right? They can put white and green, white and blue, white and red here, and then on the top of the tower, on the actual ODU, you will have another color coding as well. So you know which IF cable goes to which IF cable. On labeling as well, your Ethernet cables, you can just do a quick label for those with Ideal, a little printer, not a big deal. And label the IDUs themselves. The reason why is because, yeah, it looks really cool that it says Giga Orion, Triangle, and all the bells and whistles, right? But when you say, hey, here, take it to the side, go. Well, the problem is, if you didn't label which side is A or B, when you get to the side, when he puts it in and connects it, what's going to happen? It's not going to lock because two things can happen. You can either send the wrong ODU to the wrong side, A or B, or you can send the wrong IDU to the wrong side. If you send the wrong IDU, it's not that big of a deal. You can always reconfigure the IDU. But if you send the wrong ODU to the wrong side, you have to come back and get the other one. So be careful. Just make sure you label these guys, okay? Now, yes, you're going to have to hear me for the next 30 minutes talking about sheets, okay? Link validation forms. Again, site information, customer information, antenna information, outdoor unit information. If it's a direct mount or OEU or combiner, has to be labeled here. Power supply information. Is it a transit power supply? Is it a split mount system with an X48? Is it a PoE all-in-one? Is it a PoE injector? What is it? IF cable. Cable type, LMR 400, 600. Cable length. Is the ODU secure? And is the IDU connected? Notes, again, installation performed by, who are we going to point fingers to? Unfortunately, that's it, right? Who are we going to blame? Installation approved by, who's going to sign off on the install? When you have a 1+0 config, pretty much the information is the same. On this we have just a little more information as far as site configuration. If it's a 1+0, 1+1, 2+0. Site A configuration, Site A approval as well, and then we have all the model information, ODU serial information, polarization is a V or H. On previous models, we have for you IDU IP address, the OBM and IBM. Now you only have one. Antenna models, transmit power, speed and modulation, ACM, target RSSI, recorder RSSI. All this is repeating me a lot, but this is for you guys to get an idea of what can you actually develop your own sheet as well.
How do you recommend, I mean, there's lots of people have a lot of approaches on naming things, but how do you recommend naming and keeping straight in a 2+0 configuration? What's what? I mean, we got separate, I mean, basically it's two links.
Yes.
Working together. So
What I recommend is just from that side, I do IP and then side going to the lower side. I mean, to me it works, but I know which IPs are which. Typically, I use odd or pair numbers, so odd goes to odd, pair goes to pair, IP related to me. So I know which is the other side. And then on the prompt, labeling wise, I just put IP 100 to 102, but which is my A, which is my B side, right? Really, this is up to just your reference. I've seen people just say, "Oh, this is my band to west or tower side or mountaintop A or B," and they can live with that, right? But typically, it's up to, I would say, from 2. That's my recommendation. Just a greater than sign, and then where are you going to?
Then for 2.0, we do vertical and horizontal, so 2 microfeet vertical, 2 microfeet horizontal.
Yeah, I mean, it depends really on how you want to do it. I mean,
So when you talked about, not that I'm going there, but a 3+0 link and a 4+0 link, I mean, that's a separate antenna to do a 3+0.
correct.
Okay.
So you can do it with a single antenna.
Single antenna with
We need more.
You need a dual polarity antenna with dual waveguide coming out to 2 separate standard combiners for a 4+0 or 3+0.
Oh, okay. So it can be done with a single antenna.
Yeah, I have some pictures of that. It's
Oh, you-
becoming more common.
I'll be planning ahead a lot, but for
A little bit of plumbing involved
Yeah.
with the waveguides, that's all.
Oh, yeah. I imagine.
Because there is no combiner which puts 4 radio, that would be kind of a
maybe a monster.
contraption.
Yeah. It's too heavy for the
So you have to
antenna.
do it with waveguide and then 2 separate combiners and a dual pole antenna with dual waveguide inputs.
Does that, so they're not actually mounted on the back of the antenna then? It's just
Right.
fixed?
They're mounted on the pole,
The waveguide.
and then you've got about a 3-foot piece of flex tist waveguide going up to the antenna flange. Well, 2
See how-
flanges.
If the back of the antenna starts to get tight to the tower leg, you get crowded back there really fast.
Yeah, a little bit.
A little more than a TIE fighter in back here, dude.
Yeah, so I mean, on that note, for me, the example was more going in, if you don't have enough growth or planning to the future on expansion, and you can always do one at a time, especially for example, SL24, Starlink 24 on license, you can always add a couple of links and then just bond them at the ether channel on the switch. So, I mean, maybe it's a little simpler option, but really what you can afford on combiners is the way to go. Okay, so just site validation. Now we're getting to 24-hour traffic test. Remember that I told you guys the Rssi 2544? So you want to leave that running 24 hours or overnight. So that means how many packets I'm going to send over, it should not drop any packets, and everything should go across fine. On a 1+1 scenario, now we have a little more infrastructure. So we're going to say, which is my master, which is my slave radio, my standby radio. So again, for labeling purposes, one has to be labeled as master and one standby, or active standby, basically. Ethernet validation. Rssi 2544, how do we test it? We said before, we're going to test it from data port to data port. We don't want to test it over the network or through the switch. That's going to flood everything. You want to put it directly to the data port on one side, straight to the other. The way this works is, either device, the X or the unit, has a paired device, a slave unit. The master has the traffic generator, and then the far side is pretty much just a remote loopback device. When you plug it in, it's going to go discover right over the link. So I say, oh, I see my far side loopback device. Good. I can send my traffic, and it's going to come back as well. So once you connect both devices, you have to see the other end via the wireless link. After that, we first hand use the ideal, the one at the bottom. See that little test yellow button? You click test, and it runs the Rssi 4540, and that's all you have to do. There are more devices out there. The bigger they get, the more expensive they get as well. There's Expo, there's JDSUs, you know, a lot of brands. So it's up to you what you want to use. On this note, I do not recommend testing the link using iPerf. Okay, iPerf is not the most precise tool we're going to use for a wireless connection. The reason why, because you rely on the software of the computer, the CPU processing power, and unfortunately the results are never really consistent. You have sometimes, based on the UDP packet size as well, you will have more or less actual throughput. And it's not depending on the radio, it's actually on the computer's connection to the actual switch, to the network. So destination MAC addresses for the far side, again, iPerf is not what we encourage or recommend at all. If anything, we want you guys to use the actual handle generators.
So what's the lower one? You said that's from Ideal?
Ideal, it's called,
Like the crimper people?
yes, like the Ideal lamp tech certifier, cable certifiers.
Oh, okay.
So, yeah,
Is it Industries or is it
yes, Ideal
spelled that way
Industries. Yeah,
with the E?
Oh, sorry, I see the models right there.
Yeah. Yeah, it's Ideal Industries. I don't think that's the actual, I don't know if that's the right one. After lunch, I'll bring one of the devices so you guys can see it.
Cool.
So, and they go in the range anywhere from 3,500 all the way to 10, 20,000. But any device within 5,000 range, it's more than enough to run the Rssi 2544. You can also rent them, I believe, the Exfils for a couple of days. Then they're $80 a day or something. Now the link validation, we're going to check the validation of the RSSI with the Dmca modulation. This is not the best looking table, but we'll give it a shot. So, receive sensitivity. We've been talking about 1024 QAM link, and it's an MSE of minus 35.2. However, the RSSI is also really important because if you want to have a 256 QAM link at a 60 or a 56 meg channel, the minimum RSSI you need to have is negative 65. Anything above that, you will not be able to get a nice 256 QAM link. So you need to make sure that your RSSI threshold is enough so that it goes up and down. You have enough space to actually withstand ACM going up and down. Receiver maximum input. So this is from a 256 QAM link. QPSK will work it all the way down to negative 14 dBms. Okay, 256 will get negative 24. However, I would recommend keeping it above 32 or 30. This you're looking for trouble, but it will work. Again, in a live link, I don't think you're gonna see these numbers, but just so you know what it's the actual threshold level. Okay. Right, guys. So